And now we need to rotate that. So we hit rotate and start rotating the steps. Usually you can tell the numbers of turns from the drawing. And so from experience I can say that there's usually 1 full turn and a half. Now let's reduce the number of elements and then increase rotation and the distance. And we make sure that the last element fits precisely within the stairs and the elements are spread evenly along the spline. So it looks like our staircase is almost ready. Alright, so the last step leads to the landing. Also, the drawing should show where your rail stops. It either ends here or goes a bit further. So hello everyone, today we're going to create a spiral staircase. In your projects, you might have to model a custom staircase between the first and the second floor. For the hard nail, we're going to use a forged element that we made in the previous tutorial. Also, we're going to look into the types of rails and their creation methods. We're going to use sweep, bevel profile, and other tools. As for the steps, we're going to create them using an array object. And I'll show you how it's done. I hope that after watching this video you will learn how to create a spiral staircase of any type. Okay, here we have a space between the first and the second floor. This plane is the floor, this plane stands for the second floor, and it has an opening. We need our staircase to fit into this opening. So we create a circle spline. The circle should fit precisely into the opening. And so then we convert it to editable spline and make this object the center so that we can align all the other objects to it. So we click outline and place this point here. This is the center. Now, pay attention that we're not using a ready-made staircase from the 3D Max catalog. You can figure out how to use and customize ready-made models on your own. That's pretty easy. So, in this video, we'll be creating a staircase from scratch. So this way you'll know how to model staircases all by yourself. Alright, so we have the radius and now we need to create a step. It will be the most basic step. So we click line and model a step in the form of a segment, placing a few points along the circle. Now, it's important to say that there are certain width requirements for steps, and we must stick to them. Here's the depth is about 30 centimeters, it meets the requirements. The height of each step is 15 centimeters. Now, of course, steps come in different sizes. Now, let's see how much it is. That's 300, so that's good. It's that's within the required range. Now, so next we need to give volume to this step. So we apply shell modifier. The board thickness is 25. Let's paint it gray. And to multiply these steps along a spiral, we do the following steps. We place the pivot point in the center of the object, like this. Also, we put the step so that it's facing the center. Let's delete this point. Alright, that's done. And we'll add a tube here later. So we put the pivot point in the center that we've created earlier. Alright, that's done. And now let's add the tube. It's kind of a cylinder. We'll set the cylinder height so that the tube goes all the way up. That's enough for now. Paint it gray and align it to the object. We align it to the object that we're using as the center. And we can do it fast and easy with a quick align tool. Alright, that's done. Now the cylinder is where it needs to be. Next, we select the step. The step has the pivot point, and we go to the tools, then over to array and turn on the preview. Here you can see settings from the previous projects. Let's reset that. Alright, now the preview is on. And keeping in mind that our staircase is about 3.5 meters high, we set the number of steps and rotation. Let's start with the easiest parameter. Move along the z-axis. The distance between the steps is usually about 15 centimeters, so we enter 150. See? Here's the distance between the steps. And then we enter the number of steps, just enough to take us to the second floor. And now we need to rotate that. So we hit rotate and start rotating the steps. Usually you can tell the numbers of turns from the drawing. And so from experience I can say that there's usually one full turn and a half. Alright, so we use the rotate tool to set the number of turns. Now let's head over to the top view and see. Now there's one full turn, but the stairs eventually hit the wall. So when working on your own project, you should consult the drawing all the time. Our staircase should take us either to this landing or this one. If we choose this landing, there must be one full turn and a quarter of a turn, like this. We add a landing later, and if we choose this landing, then it's 1.5 turns. When deciding on the number of turns, you also need to consider ergonomic requirements. So for example, there must be enough space for an adult to walk upright. If you rotate your steps like this, the space will only be enough for a dog to squeeze through. So let's go back to 1.5 turns. Alright, that's good. Then we select instance in order to be able to change our steps in the future. Right, so actually we'll be modifying just only one of them. So we've created the steps using the array function, and this object has shifted. So let's realign it again. Alright, the steps are done, and now we need to create a spline for the rail. And for that matter, we go to the top view and create a helix object, a spring. We stretch it until its diameter matches the contour. Increase the height and set a second diameter. And now let's adjust the radius manually. Let's make it 795, for instance. Second rate is also 795. The height equals the distance between the floors. Let's go to the front view for more convenience. Turn off the grid. All right, so now for rotation. Now we need to make sure that the spline has the same rotation as the steps. Now we might need to switch from CW to CCW. So we rotate the spline along the X and Y and make sure that it starts where the steps start and goes along the corners of the steps. See? Now here's the spline. Here the spline misses the corner. So let's adjust the turn parameter so that the spline goes precisely along the corners of the steps. All right, now it looks better. Now we need to move the spline upwards where the rail will be, and let's make it 800 millimeters above the steps. Press W key and enter 800. The spline has moved upwards, and next we need to create the rail along this spline. Now here is the element that we've created earlier. We move it closer to the stairs and place it where it should be put. Now we need to adjust it so that it fits in between the two splines. This spline is the upper limit, so let's copy it to create the lower limit. So we might need to rotate the lower rail. So that it starts precisely in the right spot. Now mind you, you only need to do that if you must. Now you can see that here, the rail needs a slight correction. All right. Now it looks like our forged element needs to fit between these two splines. So how do we do that? First we need to adjust the height. And so let's pick the side view where we can clearly see the element. Now that we have adjusted the height, let's pull this end upwards a little bit. And don't forget that we'll add thickness to this element later. Also here we adjust the height and this bar as well. Let's make it lower and shorter. Now, by looking at this spline, we know by how much we need to adjust the height. All right, that's done. And now that we've modeled the object and the side view, now we can adjust it in the top view. So the element needs to fit along the contour. The easiest way to do that is with FFD 4x4x4 modifier. Now pay attention to how the thickness of metal rods is changing. Our forged element needs to be attached to the steps from the outside. Now here we've got a semi-circular form. If you're using a custom forged element, it might need additional adjusting. Like here, for example, we need to move it upwards. along with all fixtures. So we pull it upwards until it fits perfectly between the rails. Next, we need to set the same array for our object. So we go to Tools, hit Array, and before setting up the array, we need to set the pivot point. So we use the Quick Align tool in order to align the element to our central object. That's done. Turn on the preview. The tool already had some previous settings, so our element multiplied like so. Now let's reduce the number of elements and then increase rotation and the distance. And we make sure that the last element fits precisely within the stairs, and the elements are spread evenly along the spline. So this is the pattern that we've got. The number of elements is 12. Rotation is 46 degrees. So after you've adjusted your own forged element, you might end up with parameters different from these. But anyway, it's important that you know how to do that. To change the height, you move the elements along Z. To rotate, you rotate elements along Z-axis. And finally, you enter the count. All right, so we're done with this part. Now let's work on the rail. For the rail cross section, I've prepared this contour. This is what the rail section will look like. Now, I recommend using the sweep modifier for that matter. So we select the spline that will serve as a rail and apply sweep. And then what we do is we check use custom section and click pick and select our custom section. Okay, now let's see what we have. The rail ends, the rail end is facing downwards. It coils in a spiral shape and ends over here. Now if you check the banking option, which is usually on by default, the rail sort of twists. The banking option allows you to align the rail. Now, what do we do if we need to stretch the rail further? Suppose there's a landing here, and the rail needs to go further. So, we'll take a helix object and convert it to editable spline. Like so. We then apply sweep modifier to see its section. Next we use custom selection, click pick, and select our profile. We'll take this extreme point and pull it a bit further. Then click refine to add another point. Click corner and pull this point further. Sometimes you might also need to create a turn. And this is how you do that. So we apply sweep. If the banking option is off, our contour will look like this. To shift it to the left or to the right, we change Y offset and X offset. Now pay attention that the section is facing strictly downwards. So if you want to cut the lower section vertically, what you should do is you should use the bevel profile modifier. I mean the classic version of bevel profile. Since we use the ready-made profile, we don't need profile editor. So we switch to classic and then click pick profile. We select our contour and get a vertical section. Each loop here is vertical. The upper section is vertical also. So the bevel profile method is very popular. But keep in mind that it slightly changes the section. The section becomes thinner. The sweep modifier doesn't change thickness. So that's the difference. Plus, when using bevel profile, you may have trouble with these buttons, start and end. And in general, this modifier is rather tricky. Once again, we apply the sweep modifier with a custom section. For the bottom contour, we check enable in render and enable in viewport. The section has a rectangular form. It's one of the easiest methods, but it also causes the rail to twist. So unless your section is circular, you should better go for the sweep modifier. When using sweep, you can shift the section to the left and to the right. So let's choose a radial section and set its thickness. Now let's see if everything looks good. Here the element doesn't reach all the way down. All points are instance copies, and when we lower these points, all these elements will shift down also. Now let's see about the steps. The steps are all instance copies. So let's apply the edit poly modifier and use the extrude tool to create overlays. See, we can click grow to expand the section and apply extrude to the polygons to create these overlays. Or we can apply extrude to side only like this. The shape of our steps depends on the object that you're using to model them. It could be a line, or it can be a polygon box. So next we use chamfer modifier to add bevels. So you can really experiment with that. Let's enlarge the bevels to make them more pronounced and adjust depth. Now the bevel looks more rounded off, as it should be. Alright, so it looks like we've covered almost everything. Let's see what's left. Okay, so these vertical lintels here. When you're using array to rotate your steps, make sure there are no gaps in between the steps. So we need to add lintels here. Let me show you. We go to the edit poly level. Suppose we need to create a solid vertical lintel. So for that, we set a small extrude amount. And next, what we do is we select this polygon and extrude it down. Mind that each following step should reach to the upper face of the previous one. This is how it should look like. Now, if there are gaps, then your staircase is modeled wrong. The number of steps is not enough. So next we need to close this opening. And usually as shown in the drawings, But if we don't have a drawing, we simply create a box to fit in here. So we place this box here so that it's flush, or it flushes with the step. Let's pick a different color. So it's some kind of landing. All right. Now, don't forget to add that, otherwise your staircase will end with an opening. So it looks like our staircase is almost ready. All right, so the last step leads to the landing. Also, the drawing should show where your rail stops. It either ends here or goes a bit further. Now, I hope it's all clear with array. You can experiment with different values, but either way, your staircase should look something like this. Let's fix it a bit so that you can see the final version. We don't want to leave it finished. So we added this gap here so that the person doesn't hit their head. And here we need a rail. Let's adjust the spline, remove this segment, move this point here, and apply sweep. Next, we take one section and copy it. Straighten it out in the top view. Or you can use FFD 4x4x4. See, I took a curved segment from the spiral rail. But you can take a segment that is already straight. We'll use FFD2. Align this vertical part to the left and to the right. The pattern is being distorted, so we only apply FFD2. Only to these vertical bars. And so we need to achieve a section that is straight. Then we select this and remove this part. The pattern is a bit distorted, but that doesn't really matter. The main thing is that you see what it should look like. Copy this section once again. And here we put a bar. And now the rail. And then we go to the editable spline layer to create line. And draw that line, which is straight. All right. And so after converting it to poly, we can add a nice decorative ending to the rail. It can be some kind of twist or a bend. Let me show you how to do that. Let's take this point here, switch it to Bezier corner, and create a curve. See the overlapping? To avoid it, we need to modify the adjacent points as well. So we switch them to Bezier corner, reduce this distance, And then we do a left mouse click between the axes and raise this point. Looks like the radius is too small, so we decrease this, these tangent vectors here, and slightly move the object. By making these small adjustments, we create a bend. Now you should rely on the drawing. If there's no drawing, be creative and come up with a shape of your own. And here there's usually a bar with a decorative finial. Now my task was to show you how to create steps by using array, how to adapt these forged elements to a spiral staircase, and how to add a rail along a spiral spline. We need to use sweep or bevel profile. When using sweep, don't forget to turn on banking and adjust the offset parameters. And of course, a staircase must lead onto a landing. Okay, that's it for now. Thank you for watching. Hope you'll create beautiful staircases of your own. See ya!